Let's take a question. A stone is thrown in a vertically upward direction with a velocity of 5 meters per second. If the acceleration of the stone during its motion is 10 meters per second square in the downward direction, what will be the height attained by the stone and how much time will it take to reach there? Okay, so now let's do one thing. First is we will consider this scenario where you have something in your hand. Okay, you have a stone in your hand, and what you're going to do is you're going to throw it upwards. Okay, so now if I throw it, okay, let's forget all of that other things that come into the picture, like how much force you put into throwing it and all that. Okay, let's just focus on the stone. Okay, you're throwing the stone up and it went to a certain distance. Okay, you're throwing it up with some kind of velocity. Okay, there is some kind of speed from your hand itself, right? You're moving your hand and you're throwing it up. Okay, so it already has some velocity from your hand. Meaning what? That means that the initial velocity is present. It has some value. Okay, now what you're doing is you've thrown it up, right? It goes up to one level and then what happens? It momentarily stops in that distance so that it can come back down. Okay, when I say stops, I don't mean it just stops in mid-air and floats in the sky. That's not what I mean. I'm saying that when it goes up, okay, at some point of time, that acceleration of that stone is going to stop and that object or the stone or the ball or whatever you threw up is going to come down. Okay, so at the point where it stops at some height, the velocity is 0, correct, on top. Hence, I will take the final velocity in this case as 0. Alright, so we have initial velocity and we have also taken the final velocity. What next? Now consider this. Okay, so the object that you have, the stone that you have in your hand, you have thrown it upwards. So when it is going up, it is going against the gravitational pull. Am I right? Correct? So in this case, in this problem, if you see that they are mentioning that the acceleration in the downward direction is 10 meter per second square. Okay, so let's go back to the stone in your hand. Okay, you've thrown it to some height. Okay, and it comes back to you. Okay, the speed at which it went is different from the speed at which it stopped on top at some height. Okay, and what happens is that acceleration with which it went upwards, it is the same when it comes downwards. It's not like the ball is going to come back slower to you. Correct? We will consider that the ball came back to you in the exact same acceleration that it went upwards. Okay, but when it's coming downward, it is along the gravity. Correct? It comes on its own. Hence, when it comes downward, it is a positive value. But the same acceleration, if I consider in an upward motion, then it is negative. I take the same value, but I put a negative symbol. Okay, so if this is clear, let's go to this problem. Particularly here, the stone is thrown in a vertically upward direction. It's thrown up with a velocity of 5 meters per second. It starts with 5 meters per second from your hand, right? So, initial velocity is 5 meters per second. The acceleration of the stone during its motion is 10 meters per second square in the downward direction. When the stone has gone up and it's coming down, its acceleration is 10 meters per second square. Henceforth, I can understand that when it went up also, the value was same. It was still 10 meters per second square, but it was in the opposite direction of gravity. Hence, it is negative. Okay? So when I calculate this acceleration, I will take it with a negative symbol. Okay, what will be the height attained by the stone and how much time will it take to reach there. We need to find height, that is the distance covered by the stone, and we need to find time t. Okay, so that completes everything that we need from the question. Okay, so what we'll do next is we will summarize this entire thing. Okay, so it starts at rest, hence initial velocity is u is 5 meter per second. Since the stone comes to rest when it reaches its maximum height, final velocity v equals 0. I'm saying it starts at rest and still I have given its initial velocity because it attains that initial velocity because of your hand, right? You're moving it upwards, so it gains that velocity from you, alright, and it goes and stops at a certain height. Okay, at its maximum height it comes to rest, therefore v is 0. Acceleration upward is minus 10 meter per second square, and I explained why. Okay, so let's move on. We need to find time and distance, or the height in this case, right? So let's look at the first thing. Do we have all units in SI units? Yes, we have all units in SI units, so let's celebrate. Okay, next thing is we need to see all of the values that we have, all the quantities in the question. Okay, so we have V, we have U, we have A, we need to find S and T. If you think about it, if the question had only S, we can use 2AS equals V square minus U square, correct? And we can directly find the height or the distance. But we need to find time. It is specifically mentioned in the question. Okay, so only if you noted that as a keyword in the question, you will go and calculate for time. Otherwise, you will directly go to distance and you won't have read that you need to find time also. Okay, so that's why it's important to note everything from the question and then work on it. So what we will do is, we already know that we can find distance directly from 2AS equals V square minus U square, correct? So we'll leave that aside. For now, we'll find the time using V, U and A. So which equation? Yes, V equals U plus AT. Here we need to find what? We need to find the time. So I'm going to manipulate this equation in such a way that all my unknown quantities will be on one side and the known quantities will be on the other side, so that it is easier for me to substitute and calculate. Okay. So I've thrown U to the other side. Now I will take A as a denominator. Okay. Now I will substitute. Okay. On substitution, I will get T equals 0.5 seconds. Now you have to note, especially in this, suppose you didn't, when you're understanding the question, let's say you're writing this in an examination and you didn't note that the acceleration is supposed to be taken in negative. Okay. The minute you find time in this calculation, if you see, if you had not taken acceleration as a negative, right, you would have ended up with minus 0.5 seconds, correct? If you had gotten that minute itself, you can tell that the calculation has gone wrong and you need to recheck your answer. How? Because time cannot be given in negative. Am I right? You can't go negative in time since we don't have facilities to travel back in time. So far, we cannot take a negative symbol. Okay? Keep that very, very clear in your mind. The minute you get time equals some negative value, that means that the calculation has gone wrong and you need to recheck your problem. Okay? So, the only way to make time positive is to have a negative acceleration in this case. That is why I said, let us first solve for time. Even though the question says, find the height and then find the time, right? I decided to find time first and let you know that these are small little loopholes which will tell you whether you read the question correctly or not. Okay, so if you found the distance and then you found time to be negative and you let it be like that, then even your distance will go wrong. correct? So it is best to cross check using these kind of loopholes. Anyway, let's come back and let's conclude. The time taken to reach up is 0.5 seconds. Okay, now let's go to our good old 2as equals v square minus u square. Yeah, that is the velocity position relation. Okay, here also I will manipulate the equation in such a way that I have all my known quantities on the right hand side and the unknown quantity on the left hand side. Okay, so and on one manipulation I have s equal to 0 square minus 5 square divided by 2 into minus 10. Okay, so here on the numerator it says minus 5 square, correct? Do not calculate that as plus 25 and write the numerator as a positive. Let me tell you again. So when you have v as 0, you'll have 0 minus 5 square, correct? Here that square is only for 5, not the minus. Minus is out of this entire thing, correct? So don't square off that negative symbol and be like, okay, minus into minus is plus, and make the numerator as positive. Okay, so if you did that by mistake, again your distance will come with a negative symbol, and again you will know that you have gone wrong, because distance does not consider any direction. That only displacement will do. So only displacement will come as a negative or a positive symbol. Distance strictly will be positive all the time, right? So that is how you will know you went wrong. Okay, so be very careful when you're calculating with negative and positive and everything, because it changes your answer in this case, especially when a negative symbol talks only of direction. Okay, and it will affect your calculation also. Okay, let's move on. We'll finish this sum. The negative on the numerator, the negative on the denominator will get cancelled out, and we will have 1.25 meters. Okay, let's conclude this. The height it reaches is 1.25 meters when thrown up, and that is your entire problem solved.